The history of math is our intellectual foundation to understanding science. Science. Beautiful, awesome, wonderful science. It's the creative foundation to our ineffable future. Hi, I'm Gabrielle Burchak, and this is my podcast, Math, Science, History. I often promote my website, mathsciencehistory.com, which I built myself. Of all the hosts that I've been with, my experience with Bluehost has been the best. What I really like about Bluehost is their customer service. It is top-notch, and they are always there to help me. So if you're looking to build a website or you're looking to move to a new host, I highly recommend Bluehost. You can access Bluehost through my affiliate link, which is www.bluehost.com/track, TRACK/mathsciencehistory, all one word. Bluehost is fantastic, and they are affordable. It's only $3.95 a month if you sign up for 36 months. So if you do the math, it's $142 to start. And for me, it was the smartest business investment I've ever made. Nobel season is over. As for women in physics, the 2019 Nobel Prize went to Matilda Joslyn Gage. I know it really didn't, but please hear me out. Matilda Joslyn Gage was born in 1826 and died in 1899. She was a 19th century suffragette, an activist and organizer of the Women's National Liberal Union. In 1870, Matilda published a tract called Woman as Inventor. This tract described multiple examples of women in science who had been forgotten or, worse yet, appropriated by their male counterparts. This year's Nobel Prize in Physics and Chemistry didn't really go to Matilda Joslyn Gage. Instead, this year's Nobel Prize in Physics went to Jim Peebles, Michael Mayer, and Didier Queloz for their work on dark matter and exoplanet discoveries. These are three exceptional scientists in their own right, without a doubt. However, this year's Nobel Prize in Physics highlights the Matilda Effect. Science historian Margaret Rossiter coined the term Matilda Effect in 1993 in her publication, The Matthew Matilda Effect in Science. In her work, she explained the ongoing systemic occurrence wherein the work that female scientists do goes unrecognized while the credit goes to men. Women have been severely underrepresented in science, and though there are more and more women receiving their PhDs in science-related fields, the overall percentage of women in science has not increased significantly, simply because more men are also entering these fields as well. This is perfectly fine, as everybody in STEM matters. However, this ongoing problem of women being overlooked and their male counterparts being awarded is common. Dr. James Peebles, the gentleman who won this year's Nobel, earned it from studying the earliest moments of our universe right after it was born. From his study, he created a theoretical framework that helped us to understand the evolution of the cosmos, all of which leads us to understand dark matter and dark energy. In 1965, astronomer Vera Rubin discovered a halo of something dark that surrounded each galaxy. That matter, which was a mass, spread throughout each galaxy. She had found that the gravitational force and the orbital speed of these galaxies were similar throughout. That mass is dark matter. This was in 1965. In 1965, Vera Rubin discovered dark matter. I will say this again. In 1965, Vera Rubin discovered dark matter. Sadly, Dr. Rubin passed away 3 years ago. She never won a Nobel Prize for this discovery, which, by the way, was fundamental to astrophysics. In 1903, Marie Curie won her first Nobel Prize. However, she would not have received it if it weren't for her husband, Pierre, who advised the committee that Marie had a pivotal role in her discoveries in radioactivity. Dr. Lise Meitner, who collaborated with Otto Hahn, discovered nuclear fission. And even though Niels Bohr nominated Dr. Meitner first and Dr. Hahn second, the lone winner of the Nobel Prize in 1944 went to Otto Hahn, and he never included Dr. Lise Meitner as a co-author. Dr. Marietta Blau, an Australian physicist, did pioneering work with the pion. She, along with female physicist Hertha Wambacher, were even nominated for the Nobel by Erwin Schrödinger. However, they were passed up, and Cecil Powell received the Nobel Prize in 1950 for his development of the work that utilized Dr. Blau's discoveries. Then there was Dr. Cecilia Payne, whose dissertation proposed that stars were composed of hydrogen and helium. It was her advisor, Henry Norris Russell, who was nominated for the 1953 Nobel Prize. Russell did not win his prize. Instead, it went to Frederick Zernike for his invention of the phase contrast microscope. In the 1950s, Dr. Chien-Shiung Wu, the First Lady of Physics, was conducting work on the radioactive decay of the unstable isotope cobalt-60. Long story short, in 1956, she found a large asymmetry in her experiments on cobalt atoms. However, physicists Tsung-Dao Lee and Chang-Ning Yang, who were conducting further experiments through the guidance of Dr. Wu, won the Nobel Prize in 1957. Then there is Esther Lederberg, a renowned microbiologist who, along with her husband, created a new method of replica plating, which was a new convenient way to transfer bacterial colonies from one petri dish to another. This opened the door to future studies in antibiotic resistance. This method of replica plating was essential for her husband to receive the 1958 Nobel Prize for Physiology or Medicine. We must not forget Rosalind Franklin, a British biophysicist and DNA pioneer. While at King's College in London, she had to leave the building every day at lunch because women were not allowed in the cafeteria. Unhappy at King's College, she eventually left. However, senior scientist Maurice Wilkins, during her move out, got a hold of her notes and took key images from them. He shared that information with his friends, who among them was Francis Crick. Crick went on to win his Nobel Prize in 1962. In 1967, Jocelyn Bell Burnell discovered the pulsar. However, in 1974, the Nobel went to Anthony Hewish and Martin Ryle for their work with pulsars. Dr. Bell was a student of Dr. Hewish at the time of her discovery. The list goes on. Trota of Salerno, the 12th century Italian physician who wrote books on her work, continues to be unnamed because all of her work was attributed to male authors. Pandrosian, the female math teacher in 4th century Alexandria, was written into our history as a man. Dr. Alice Augusta Ball, the brilliant African-American chemist from Seattle, found a revolutionary treatment for leprosy. Arthur Dean, who co-taught chemistry with her, continued her work and got all the credit. Dr. Nettie Stevens, the genius geneticist who, while working with mealworms, discovered that male mealworms produced sperm with X and Y chromosomes, and females produced cells with only X chromosomes. However, all the recognition went to Thomas Hunt Morgan. Dr. Mary Whiton Calkins, psychologist and philosopher who made groundbreaking discoveries for her work on stimuli, is attributed to George Elias Muller and Edward Titchener. Dr. Martha Gautier was a medical doctor and researcher who discovered the chromosomal abnormality that causes Down syndrome. All of her work is attributed to Jerome Lejeune. And then there was Dr. Marion Diamond, who discovered the phenomenon of brain plasticity. In 1964, she was about to publish her paper on this work when she discovered that two other authors, David Kretsch and Mark Rosenzweig, had their names placed before hers. Dr. Diamond protested, and her name was given first place. She rocks. Then there are the female unnamed heroes who were part of the programming ENIAC, the Electronic Numerical Integrator and Computer. These amazing women include Adele Goldstein, Kay McNulty, Betty Jennings, Betty Snyder, Marilyn Westkoff, Fran Bilas, and Ruth Lichterman. The list goes on and on and on. Women's efforts in science are not less important than men's efforts in science. They are equally important. Our greatest developments in science can only come when diversity is welcome and embraced. So, how do we fix the Matilda effect? There are so many ways. The answers to fix this are right in front of us, and it's been said over and over and over again, but I'll say it too, because I have a podcast. So here are the things I think we need to do. 1, recognize our unconscious bias. We all have it. It's there. We need to recognize it. 2, create committees that are more diverse. And I'm not just talking about gender diversity. I'm talking about race diversity as well. 3, create a transparent process that defines the selection process. This transparency is essential. It allows for the input of those on the outside to recognize the unconscious bias. 4, rewrite the material. Rewrite it all. Change the language. Make the words less gender specific. Words have power. All of our words have so much power. So when we write these awards, let's rewrite them so that when we propose the awards, there's no confusion as to who can apply. If everybody can apply, then that needs to be specifically clear. This is also necessary for the evaluation process too. 5, create nomination pools in such a way that there are equal amount of women as there are men in the nomination pools. And if we find that men are still winning more of these awards, let's go back to point number 1. Let's evaluate our unconscious bias. Number 6, men, step up and be more like Erwin Schrödinger and Niels Bohr. Nominate women, please. We need this. There are many, many, many brilliant women in the world who deserve to be recognized for their efforts. 7, finally, please don't be complicit. Call out bias when you see it. Calling it out helps to normalize the reality that women are highly qualified scientists too. 8, scientific journals, please help us to change the bias by looking at how many papers are submitted by women versus how many papers are published by women. And 9, women, publish your work and keep trying to publish your work. Please be active about this. Your work matters. It matters to science. It matters to other women in science. It matters to our diversity. It matters to our daughters. And most importantly, it matters because we want to celebrate your work. I'm Gabrielle Burchak. This podcast has been brought to you by caffeine. Delicious, wonderful nectar of the gods caffeine. Coffee, tea, coffee candy, you name it. I love it. Thank you for listening to Math Science History. If you like what you are listening to, please remember to subscribe and leave a review. I would really appreciate that. If you are interested in reading more about the history of math and science, please come visit me at mathsciencehistory.com. And while you are there, if you like what you're listening to, please feel free to click on that coffee button and buy me a cup of coffee. Until next week, carpe diem.